we're asked to solve this equation, which is a quadratic form. You'll notice in the next line I've written it so that we have 2 times something squared plus 15 times something minus 50. And in fact, inside the parentheses, we can write x squared and x squared because that is equivalent to the original equation. At this point, I will do a substitution. I will let u equal x squared. And so doing that will allow us to write 2u squared plus 15u minus 50 equal to 0. Now we have a quadratic equation that we can solve. I'll use the quadratic formula to do so. Here we have a is 2, b is 15, and c is negative 50. Solving for u, we'll have u is equal to minus b plus or minus the square root of 15 squared minus 4 times a times c all over 2 times a. In this case, simplifying a bit gives us u equal to negative 15 plus or minus square root of 225 minus 2 times 50 is 100. 100 times 4 is 400. Notice we have a subtraction of a negative, so this will be plus 400. That will all be over 4. Continuing to simplify, we have negative 15 plus or minus. This is the square root of 625, and it just so happens that 625 is a perfect square. It happens to be 25. And so we have this. Now we can separate this into u equal to negative 15 plus 25 over 4, or u equal to negative 15 minus 25 over 4. One additional step allows us to figure out the values for u. Negative 15 plus 25 is 10 over 4, which 10 fourths reduces to 5 halves. The other solution would be negative 15 plus negative 25, which is negative 40, divided by 4 is negative 10. Now remember, we're not solving for u, we're actually trying to solve for x. So what we have to do then is we have to substitute x squared for u. So I make a direct substitution, and I have x squared is equal to 5 halves, or x squared is equal to negative 10. By the square root property, I will take the square root of both sides, and I will get x equal to plus or minus the square root of 5 halves, or x equal to plus or minus the square root of negative 10.